So I'm here today with Rowan Williams from BASF. We're talking about compostable polymers. Rowan, can I get you to introduce yourself and your various roles in the industry?
Sure. Thanks, Jed. Morning. So I work for BASF Australia, and I'm in charge of regional market development for biopolymers, as we call them, for Asia Pacific. So I look after all the countries in Asia Pacific, and I support market development in China. In addition, I'm also the president of the Australasian Bioplastics Association that represents members on advocacy and stakeholder management for all types of bioplastics. I'll explain different families shortly. And I'm also a director of the Australian Organics Recycling Association to help educate and familiarise the organics recyclers on the use of specifically compostable plastic.
And you mentioned different families of biopolymers. What sets them apart? What are the differences between the various biopolymers?
You have fully bio-based conventional plastics, if you like, where the carbon source has been replaced with a renewable material. So, for example, instead of PE or PP, which you'd be familiar with, we replace the carbon with sugars or other fermented renewable raw materials to make bio-based PE, polypro, polystyrene, polyamides, and so forth.
Okay.
And are designed for the conventional or mechanical recycling streams. So a bio-based PET, for example, is indistinguishable from an oil-based PET. They can be processed together and has no impact on the recyclers. So that's that family. Definitely designed not to be composted, do not have the inherent properties of biodegradability. They're designed for the conventional recycling streams. The other family is, of course, those that we refer to as compostable and preferably certified compostable, being certified to one or other or both of the Australian standards destined for organics recycling or composting or AD at end of life. So they're very distinguishable. We have fully bio-based for conventional mechanical recycling, and we have certified compostable and therefore biodegradable, destined for organics recycling. The only way to prove that something is biodegradable is to have it certified compostable, where the biodegradation tests sit within those standards.
With certified compostable being very important, as you discussed, that's about end of life. What applications are then suitable for compostable polymers?
So the base rule or the base philosophy is packaging or containment of food waste. So let's look at it, say, from your caddy bin liners on your kitchen bench, or maybe a compostable garbage bag in a restaurant or commercial premises, where food waste can be source separated into that bag and go off with green waste or other food waste or organics collection. Food service type items is an application today. We'd like to think that more problematic packaging that today is condemned to landfill because it's food soiled or had food cooked on it, or howsoever the food is there, then a package like a tray or a freezer chip bag or whatever you might find in your pantry or in your freezer that contains food, which today, because it's contained food, renders it neither reusable or recyclable, then that might be an application for a compostable polymer. But there's obviously a lot of thought that needs to go into that, because you have to think about barrier properties. We don't want to increase spoilage of food. So there's a lot of things you need to work through to make sure that it's appropriate.
For a lot of our customers, film manufacturers, injection molders, people that may be looking to use compostable where it is a suitable solution to a problem that their customers have. A lot of questions we get is around, well, okay, what does that polymer look like? How do I process it? What are the end properties versus a conventional, say, polyolefin or other polymer that they're using?
Okay, well, largely speaking, I mean, I'll use BASF as an example. We have our EcoFlex and EcoVO, for example, and it's similar to a lot of other products out in the market with different trade names. But essentially, they process exactly the same as polyethylene on conventional equipment. There may be minor changes such as temperature and speed and other processing factors, but largely they process in the same way on existing equipment.
Yeah, and I guess the experience we've had in seeing those polymers used, that's certainly what we've seen. That in the end, it's not too much trouble to be able to make the product the customer's looking to make. Rowan, really appreciate your time today. I think the audience and our customers will have learned a lot about the difference between the different biopolymers, as we call them, and compostable polymers specifically, and where the applications are that are suitable for those polymers. So really appreciate your time today, and thank you very much.
No problem.